discussing about JFET. Today we are going to discuss about MOSFET, biasing, and we talk about this. Anyway, leave this. We'll start afresh. Okay. So suppose this is a MOSFET, enhancement type MOSFET. Okay. We have resistance RD here. We have VDD here. Suppose we are giving some supply VCC here. Okay. So first thing which when we solve or we'll try to find out this V output, we are interested in this. This is nothing but this is VDS, this is drain, this is source, this is gate. So this, what is the value of this gate current? The value of gate current. Hello, can you hear me?
Yes, sir.
What is the value of this gate current? कितना होगा current?
Sir, VD minus V naught upon RB, RD.
So I think you forgot the working of this. This is MOSFET. This is source. This is drain. Okay. So when we apply, this is metal actually. This is metal. This is oxide. Right. So this is metal oxide semiconductor. So this is nothing but it is a capacitor. So when we apply positive bias here, this gate voltage is positive. It is going to attract the electrons. And there is channel formation. So if you see, we have now electrons here this way, right? So this is, and if you see, we have this PN junction here. This is P. So we have depletion layer here, isn't it? Depletion layer होगी ना जब P और N junction होंगे. One is this, another one is this. Okay, but if we apply positive bias here, we have electrons here. This is nothing but this is channel. And this is depletion layer of a PN junction. So we have electrons here, here, ऐसे electrons हैं. If I apply a battery here, like this, electrons will be attracted towards the positive terminal, and the flow of current is like this. Okay. And if we apply the negative bias at the BG, so this is NMOS actually. If BGS is positive here, right, ID flows. Okay. If BGS is negative here, what is going to happen? What should be the value of ID? Hello? If we apply the negative potential here, so this is something like this, that if I apply a negative potential here, it is going to attract the holes here. So we have holes here, right? So this depletion layer is definitely going to increase. Okay, because we have junctions here. There are two junctions, and the current across this will be 0. 0 हो जाएगा ना? We don't have any charge carriers to flow if we apply some potential here. So that is the problem with this. So this channel is not formed here. So ID is 0 in this case. And what is the value of current ID? IG? IG कितना है? So IG current means this flow of. So do you see any charge flowing from gate terminal? Hello? There is no charge flowing because we have oxide layer here. So this Ig is 0. And the input resistance of this is very high. It's very high in this case. Okay. And what is this ID? So if we apply positive, so definitely ID will be flowing because this is NMOS. Okay. So what should be the V output? It is VDD minus ID. Okay. So if you see here, now V output is VDD minus ID. ठीक है? So V input is suppose VGG, that is positive. Okay. So V output is VDD minus IDRD. Okay. So as current ID is increasing, so V output is tending towards 0. And if VGG is negative, VGG और VGS भी बोल सकते हैं इसको, because source and this they are connected. Okay, so this is becoming VGS. Source is at ground, so we have VG here. So if VG is negative, ID will be 0. What should be the V output? It is VDD. So if I just change this is VDD, or I'll change this 0. So input is VDD, output is 0. And if his input is 0, output is VDD. Do you know which gate this is?
सर XOR है.
This is not gate. है ना? Okay. And if we talk about this, if I change this from PMOS to NMOS, NMOS to PMOS, sorry. This is P, this is PN now. So in order to form the channel, what voltage I should have to apply at gate so that I can form the channel? It should be negative so that it can attract the holes here. And electrons will be repelled towards this side. Okay. So what we have is, we have this channel is formed of holes now, like this. And if I apply some potential here, so holes will be attracted towards this side, like this. But I need current opposite to this. So I should use battery like this. This is something. So at VGS is 0 or negative voltage, or we say low voltage, PMOS is on, basically. And if VGS is positive, high, PMOS is becoming off, as no channel is being formed. Right? So if if we see about this is NMOS, right? And this is symbol of PMOS. Okay, so this 0 is going to signify that for 0 it is on, and it is for high it is on. That's it, and opposite is true. So if I just form a circuit from here, like this, are you able to understand ना? समझ आ रहा है नहीं?
Yes, sir.
Okay. So this is NMOS. This is PMOS. This is NMOS. थोड़ा सा चेंज करता हूँ जरा. So this is input. This is V input. Okay. This is VDD. This is ground. This is V output. देख पा रहे हैं? Q1 is, अब देखिए, I'll draw a chart here. this is the input. Okay. Suppose this V input is high. I'll take it VDD. Right. Now I hope if this is VDD, what should be the output? VDD means high. ये 5 वोल्ट ले ली मान लो. So PMOS is on or off? Hello. Just write down your answer. I just want to see. When VDD is positive, Q1 should be high or low. Q1 should be on or off. Or I say this PMOS is on or off. I want everybody's answers in the chat box. I'll ask also. All of you, just start writing your answer. Are you able to hear me? Hello. Write down your answer when VGS is positive or VDD. तो क्या आउटपुट आएगी? हेलो. PMOS
sir.
on होगा ऑफ होगा? Hello.
Yes, sir.
Yes, sir.
PMOS is on or off? Just write down your answer in the chat box. Every one of you. है ना? Hello. I just find only one answer. एक ही स्टूडेंट ने जवाब दिया है अभी तक. I want everybody's answers. Just type it on. My question is this VDD is this PMOS is on or off? बाकी लोग क्या कर रहे हैं भाई? तो 10 ही लोगों ने लिखा अभी तक. 60 लोग हैं ना क्लास में कम से कम. Okay, very good. Hanji. So I'm quite sure that none of you is attending the class actually. सिर्फ एक बच्चे ने सही जवाब दिया, बाकी सब ने एक दूसरे का देख के लिख दिया. तो इट्स आई एम नॉट फोर्सिंग अपॉन द क्लासेस अपॉन यू. ओके, आपको नहीं लगानी है क्लास, कोई बात नहीं, बट आप क्लास में ऐसे एब्सेंट रहोगे तो क्या फायदा, है ना. मतलब किसी एक सेकंड भी नहीं हुआ मुझे इस बात को बताए हुए दैट अभी समझाया मैंने. यहाँ देखो, दिस इज PMOS, that when we apply the negative potential here, positive potential here, if VGS is negative, this is on. If VGS is high, PMOS is off. बल्कि यहाँ लिख के दिया सारा, एक सेकंड भी नहीं हुआ इस चीज का. I have explained the working of both the MOSFETs here, but even though आप में से कोई भी यहाँ प्रेजेंट नहीं है, कोई सुन ही नहीं रहा है, इसका मतलब है जस्ट वो लगा दिया है बस, दैट्स इट. So anyway, no issues. So if we go for this is going to be off and this is going to be on. So circuit becomes like this. ये short circuit हो गया, ये open circuit हो गया, because this is off, this is on. And you see this power supply, this B output is connected to which point now? This 0 volts. So B output is nothing but 0 volt here. Okay, that means when this B input is VDD, PMOS is off and MOS is on, and B output is nothing but 0. Now if it is 0, okay, now if this is 0 volt, suppose, which transistor is going to turn on? कौन सा ऑन होगा, कौन सा ऑफ होगा? So PMOS is on. On means its resistance is 0 एक तरह से, okay, and off means its resistance is high, infinity. It is open circuit. So now this B output is connected with what? VDD, isn't it? So I just draw this, that it is on and this is going to be off, and the output is VD, right? And if you see the relationship between input and output, what is it? If input is high, output is, तो कौन सा गेट हुआ ये? Not gate. This is also called as complementary MOSFET, CMOS basically. We have two MOSFETs which are complementing to each other. कि एक ऑन है तो दूसरा ऑफ है, एक ऑफ है तो दूसरा ऑन है. इसको इन्वर्टर भी बोलते हैं, बिकॉज आउटपुट इज इन्वर्टेड. इनपुट ये है तो आउटपुट क्या होगी? ए बार इन्वर्टेड, और दिस इज ऑल्सो कॉल्ड एज नॉट गेट. ओके, इसको सीमॉस इन्वर्टर बोल देते हैं, this circuit. So this is how it is going to work. So you have to understand it's working. Okay. अब मान लो ऐसे बनाता हूँ मैं, दो गेट होगा. This is A, this is A, this is B. This is Y. Right? So if A is 0, so if you see here, if A is 0, B is also 0. This is 0, this is 0. कौन कौन से ऑन होंगे? This is going to be off, right? And these two will be on. So Y is connected with what? VDD. Right? So this output is Y is 1 then. If one of them is 0 and 1, if it is like that, so situation will be, this is also off and this is on basically. ये on हो जाएगा, लेकिन ये off है. So Y is again connected with VDD, that is 1. Opposite is true for this one. Now if we talk about this, if both are 1, so कौन सा off होगा? This is going to be off, this is going to be off, and these two will be on, and this is connected with 0. So if both are 1, output is 0. Okay, so Y here is nothing but equal to A dot B bar. Which gate is this? Which gate? NAND gate. वही है ना?
Yes, sir.
Yeah.
Now, if I go for this, अब उल्टा कर देते हैं। PMOS को दोनों को सीरीज में कर दिया और NMOS को पैरेलल में कर दिया। So this Y is becoming A plus B का Y. Which gate is this?
NOR gate.
NOR. ठीक है, तो you just have seen कि when both are this PMOS are in parallel and NMOS are in series, it is like this AND gate. Okay, इसका कॉम्प्लीमेंट कर दिया, मान लो A डॉट B का कॉम्प्लीमेंट कर दिया, इनको सीरीज में कर दिया और ये पैरेलल में कर दिया. So it is becoming NOR gate. So this is how we are making the gates using MOSFET. आपने तो ऐसे पढ़े हैं ना? क्यों? आपको लगता होगा ऐसा ही होगा कुछ गेट? Am I right?
Yes, sir.
Yes, sir.
है ना, कुछ ऐसा डिब्बा सा होगा एक. हेलो, है?
Yes, sir.
इस डिब्बे के अंदर ये है बेसिकली, राइट? ये हो सकता है बीजेटी बेस्ड भी हो सकते हैं, डायोड बेस्ड भी, तीनों तरह से बना सकते हैं हम गेट्स. बीजेटी से भी गेट बना सकते हैं, डायोड से भी, जेफिटे से भी और मॉसफेट से भी. ओके, इसको क्या करना है, ऑन और ऑफ वाला सिस्टम बनाना है, दैट्स इट. वी वांट टू यूज देम एज ए स्विच. So for digital type behavior, what we should know is that how they are turned on or off. Okay, अब you know how to make them like that. जैसे मान लो यही है, ऐसे स्विच बनाते थे ना हम गेट्स के लिए. Have you seen this type of structure? For the representation, a bulb is there,
Yes, sir.
है ना? Input is there. This is A, this is B, something like this. This is A plus B, yes, like this. और यही सीरीज में होंगे तो
A dot B.
like. बट ये स्विच की जगह क्या है? These one. Okay, so input can be like this. मान लो इनपुट ऐसी है, राइट? ये A है, ये B है, B ऑलवेज हाई है, और NAND गेट में दी तो क्या आउटपुट आएगी? y is a dot b bar. Miss, जब when both this is 1, this is 0, this is 1, this is 0, this is 1, and this is always 1. ये always 1 है. Okay, तो 1 1 क्या होगा? If both are 1, output should be क्या होनी चाहिए? क्या आउटपुट आएगी? 0. 1 into 1 bar क्या हुआ? 1 bar, that is 0. If any of the input is 0, output should be 1. Like this. तो इस तरह की आउटपुट आएगी. Okay, these are signals actually, digital signals. Fine. So this is how the BJTs or these they are used for the digital application. You know any digital application? Hello. आजकल तो सब यही है ना, कैमरास डिजिटल हैं,
यस सर.
टीवी, सब कुछ तो डिजिटल है. योर कंप्यूटर्स,
डिजिटल वॉच.
वॉचेस, और क्या है? मोबाइल फोन डिजिटल है नहीं?
यस सर.
ओके, सब कुछ डिजिटल यूज हो रहा है. दैट मीन्स इन द फॉर्म्स ऑफ जीरोज एंड वंस, दिस टाइप. यही सिग्नल है वहां पे, लाइक दिस.
जिसमें भी ट्रांजिस्टर यूज हो रहा होगा वो तो डिजिटल होगा ना.
जिसको ऑन ऑफ कर सकते हैं, switching behavior. That's why we are using these semiconductors, because they can be having very high resistance or they can be have very low resistance. तो कंडक्टर की साइड भी जा सकते हैं और इंसुलेटर की साइड भी जा सकते हैं. इंसुलेटर मतलब ऑफ, कंडक्टर मीन्स ऑन साइड. Okay, because they have behavior in between them, right? वैसे ही एनालॉग और डिजिटल कम्युनिकेशन है. अब कम्युनिकेशन करनी है, मान लो कम्युनिकेशन की बात कर रहे हैं. So there are three important portions of a communication. One is transmitter, another one is receiver, and this is called a channel. Okay, signal is being transmitted from here, passing through this channel, reached up to this receiver. जैसे सपोज मेरा और आपका मोबाइल ही है. This is mobile 1, this is mobile 2. तो सिग्नल कहाँ जाएगा? थ्रू एयर. यहाँ टावर लगा होगा, isn't it?
Yes, sir.
It is going to receive and sending it to some receiver. In between what is having, we are having air, right? And during this process, जो सबसे बड़ी hurdle है, that is noise actually. Okay, so noise is being easily added into this signal. So in order to avoid the noise, we go for digital communication. Okay, तो ट्रांसमीटर का काम है ट्रांसमिट करना सिग्नल को, एंड अनदर वन इज रिसीवर, एंड दिस इज चैनल. लेकिन जैसे मैं वो कोई बात कर रहा हूं, whatever I am speaking right now, that is audio signal, that is from 20 to 20 kilohertz frequency. Okay, इस तरह से सिग्नल होगा. This may be something like this. Whenever frequency is less high, its amplitude can be high or its amplitude can be low, depending upon this. है ना? So, one thing is this amplitude, another thing is this frequency, and third one is that is phase here. Okay, so तीन चीजें बदलेंगी. But this, whatever I am speaking, that is in microvolts. तो मेरी आवाज 5 मीटर 10 मीटर से ज्यादा नहीं जाएगी. ओके, am I right? थोड़ी नॉइस कम होगी तो 20 मीटर रख लो, जोर से आवाज लगाऊंगा. But my voice is reaching up to you. You may be at 500 kilometers, okay, away from me. So in order to make or reach it up to a distance, what we need is we need amplifiers also. Amplifiers की जरूरत पड़ेगी ना,
Yes, sir.
तो इसलिए amplifiers, BJT as amplifier, MOSFET as amplifier, ये पढ़ रहे हैं ना हम लोग, तभी तो ऑपरेटिंग पॉइंट्स हमने पढ़े. ठीक है. So any questions from today's class?